Let's try to record a day 2 video on our last series, on the series that we started in our last video. Today, with a slight improvement, I have a mic attached with my phone. I don't know how it sounds. So, this some seconds are to check whether mic is working properly or not. I think it's enough. Let's check. It's working fine. Oh, let's go to our next video. So in last class we discussed about position, and I did tell you the basic idea of position. What is position? What do we mean by position in physics? The things that I didn't tell you are its formula, definition, etc. So I summarized some important points about position on my board that I would going to share you. Here it is. Here it is. I also provide the screenshot or a photograph of this board. So let me take a photograph, then we will proceed to our next part in our journey to explain these Maxwell's equations. Okay, look at them closely. I saw the last video. It was not appear that this is just a photograph given in NCERT in electromagnetic waves. Okay. I have not yet started the video because there is so let me rub it out. Okay, now what? We have started with our first video with the first lesson about Maxwell's equations. Zero, 2, and we have already discussed about positions. So the next thing is what is velocity? If we figure out what is position, then we can talk about velocity. What is we mean when we say velocity or discussed about velocity? These things seems very easy to you because it's a rate of change in position with respect to time. It's just it. So what are the new things that I can add to it? Nothing. It's fine. It's fine that velocity Uh, I think I have to switch the back camera. So the velocity, that is velocity is just defined as velocity is just defined as rate of change in position. This is velocity. What do we mean by rate of change in position? Suppose initial position. Suppose we have a single coordinate system. It means the motion is only happens on a straight line. Why? Because this is the most simple case of velocity or of any quantity. Therefore, we need to understand in first one dimension. So, initial position is suppose x1, and the final position would be x2 at time t1 at time t2. So this is the conditions. So now we can find the rate of change in position. What change in positions occur? x2 minus x1 divided by t2 minus t1. This is called velocity, or I just write v. And the unit is meter per second, or you can write meter per second. So that's it. This is the velocity. We can write this formula in some other ways also. Means if you know that a symbol delta, this is called delta, it denotes change. So formula of velocity can be written in form of delta as change in position upon change in time, meter per second square. And if you know about delta change, and maybe some of you didn't know, but most of you know about the even smaller change, or the change which can be only described by mathematics is called t. Small d is a symbol, and this denote differentiation. And in terms of this smaller change, dx by dt, meter per second, sorry, here is a square, this is -1, this is -1. So this is the formula of velocity in a differential form, or you can say it's a differential equation of velocity. This you can simply understand, and this is also. But what this means? It means If you have, suppose a problem, if you have some value of x1, x2, t1, t2, you can put this value in this formula and you would get the velocity. Or if you don't have the exact position of x1 and x2, but you have the change in position is given in the question and the time taken is also given, then this formula is just enough. Just put the change in position, change in time, this will give you the velocity. Okay, when this formula is applicable, you would face some problems, or some of you already knows, sometime the position is not given as values of 2 meter, 5 meter, 10 meter, etc., or in terms of coordinate 2, 5. As in some situation a formula of position itself is given in the question, means position is given as a function or an equation in terms of time, like x is equals to 4t square plus 1. This is not a typical position or this meter per meters. Okay, it's a position. In this situation, if you want to find the velocity of this body whose position changes with time, then its position varies at each and every time. At t is equal to 0 seconds, the meter would be the 1 meter, the position would be the 1 meter, and t is equal to 1, it is 5 meter, and t is equal to 2, it's 8 plus 9 meter. So it's change at each and every time. In case of these type of position or any other function of position, the velocity is also comes as a function. So how do we derive the function of velocity? By differentiating the position with respect to time. How the differentiation, you have to know some things, some basic things about differentiation to proceed in physics. Not too much, some formulas, some basic ideas, it's just enough to do all the things in physics. And whenever required, you can learn the maths required for it. So guys, the velocity, I think we have stopped here because it's become too long. If I get to our next thing, oh, one more thing I want to tell you is that in last formula we have know that position can be in terms of vector x I cap plus y j cap. In this situation, velocity is also vector quantity. Its direction depends upon acceleration. So in terms of this, we can write dr vector by dt, or d dt by xi yj, or v is equals to d dt xi dy dt j, and this will give you the velocity in terms of x coordinate, let's say vx in I direction and vy in y direction. So this is the velocity in vector form. in two coordinate system. Start I think I did tell you that we start with the uh, one coordinate system, that is straight line, and the same thing is can be written in terms of addition. The vx vector, vx part, or the part of velocity along x-axis, the part of velocity along y-axis. It's carry on in other topic also, so it repeats with different symbols for acceleration, for force, for anything which can be related to this. So this is the velocity. I can provide you a view of the board. You can write these things on your notebook. Okay, fine. I think the board work is over. Let's close it out. So with my bad English, I did explain to you what is the velocity, how when Maxwell equation comes in picture, it's takes some time. You have to know all the things before that. It's a conclusion. My aim is not to just tell you Maxwell equation with Maxwell equations. It's a goal, during the journey, what we learn, that is position, velocity. After that, I think in next video we will discuss in acceleration, what is acceleration means, and what is graphical relation means, and this will go on and on. The aim is to create a foundational series of videos which are not burden, which he can learn things with ease. It take some time, but deeply, and understand things. Okay, let's close it. The next video would be about acceleration. So bye. Let's close it.